Hi everyone. Today's topic will be the time value of money. What are we going to discuss today? We're going to see timelines, future value, present value, continuously compounding methods, different classification of interest rates, what are annuities and perpetuities. So let's start. The first thing that we do when we approach a problem is to draw a timeline. We need to understand when each and every cash flow is expected. Now, cash flows can be cash inflows or cash outflows. That's the first thing we need to understand. Cash inflows are representing money that is getting into your pockets. Those will be positive cash flows. Cash outflows will be money that are leaving your pockets. Those will be negative cash flows. In addition to that, we also need to describe when each and every cash flow is taking place. So the first thing we do is to draw a timeline. Usually on top we write the periods or the years. So 0 represents the present time. This is time 0. Number 1 represents period number 1 or year number 1. 2, year number 2. 3, year number 3, and so on and so forth. Now, in many cases, we'll call them periods. In other cases, we'll simply say years. It really depends. Later on in this course, you will see also that cash flows can be taken semi-annually, once every 6 months, quarterly, monthly, weekly, daily, and so on. But for start, we will see annual cash flows. 0, 1, 2, and 3 represents years. Below the line, we usually write those cash flows. Like I said before, it is possible to have positive cash flows or negative cash flows. In addition to that, to understand what is going on, we also want to represent the interest rate that you may get or that you need to pay, and this is something that we also write on the timeline. Now, for simplicity, we assume that cash flows occur exactly at the end of each time period. Why is that? Because it simplifies our problems. In many problems, it is possible to see that cash flows are taking place every couple of days, but we usually accumulate them and we just represent them at the end of each period. In addition to that, we're going to describe either finite timeline or infinite timelines. We're going to see that in a couple of minutes. Here are a couple of definitions. What are lump sum and what is an ordinary annuity? A lump sum is a big chunk of money that we're getting or paying. It really depends whether it's positive or negative cash flow. But this takes place only once at the end of the time frame. So here is a lump sum of $300 due in 2 years. Pay attention, nothing happens today at time 0. Nothing happens in year number 1. But after 2 years, we're expecting to receive $300. As opposed to that, what is a 3-year $100 ordinary annuity? The definition of annuity is equal payments starting from the next time period for a limited time period. In this case, for 3 years, the $100 will start at year number 1 and will continue for year number 2 and year number 3. Those are equal cash flows starting from 1 year from today, 1 period ahead of us in time, for a limited time period, in this case, 3 years. What is a typical cash flow stream of projects? In many projects that we will learn later on how to finance, you're going to see that first you need to invest and then you're going to receive some cash flows. In this example, first of all, at time 0, at present time, you need to invest $70 or $70,000 or $70 million. You can write whatever you want here. Later on, you will start to receive cash flows. For example, in year number 1, you will receive $30. In year number 2, $110. But gradually, the project will decay and will end. So at year number 3, we expect a lower amount of cash inflows, $60. So eventually at year number 4 we can think that the project completely dies out and the cash flows are zero. Pay attention that at the beginning cash flows are negative, which means that money is leaving your pocket. You need to pay in order to start a project. First you need to invest. After that you will start to see return, more return, but gradually the project will decay, will decrease, and will generate less and less cash flows. If we'll portray that over a graph, you can see that cash flows, first of all, are negatives. First of all, you need to invest. Then you're break even, you're starting to earn money, you reach your peak, but gradually it will decay. Now that's only a typical cash flow stream for a typical project, but obviously it doesn't have to be all the time. Different projects can take different forms. Let me give you a quick example. If we think about a motel, for example, you think to buy yourself a motel and then start to rent the rooms there for guests. So first of all, you need to invest, and then you will start to generate some positive cash flows. After a while, you want to invent more in this motel. Maybe you want to buy a pool. Maybe you want to upgrade the rooms. So you need to invest some more. This other project will be first a negative cash flow, then you generate positive cash flow, but then again negative cash flow because you need to invest more in order to generate additional cash flow. So different projects can take different forms, but this is usually what we see. First there is some investment, and later on there is some cash flow stream of positive cash flows, positive money that you will generate, but sooner or later the project will die out. Let's understand two more terms, present value and future value. Present value represents the value of the money today, while future value represents the value of the money in the future, sometimes into the future. Now, present value will represent by the letter PV, future value with the letters FV. So here is a question. What is the future value of $100 today after 3 years if the interest rate is 10% per year per annum? The first thing that we do is we draw this timeline from 0 to 3 because this is our time frame. And we put the years, year number 0, which is today, year number 1, year number 2, year number 3. $100 is today, and then we also record the percentage, the interest rate that you should get, 10% on top of this timeline. And the question is, what is the future value of this amount? This is a pretty simple example. Why? Because you can invest the $100, put it in the bank, and earn 10% per year, per annum. So after the first year, the $100 will grow by 10%. So what we do is $100 times 1.1. Why is that? You always multiply times 1 plus the interest rate. 1 will give you the principal back, plus the interest rate of 10% will give you also the interest rate return. So $100 times 1.1 will give you 110 in year number 1. Now take the $110 that are already located here in year number 1 and multiply times 1.1 again to compound it one more year into the future and place it in year number 2. This will give you $121 in year number 2. This process of translating present value into the future again and again and again is called compounding. In a second you will see that the opposite a shift of money from the future back to the present is called discounting. But let's stay for now with the process of compounding. Let's solve our problem. What is the future value of $100 in 3 years with an interest rate of 10% per year? Here is the solution. Future value in year number 1 is the present value times 1 plus the interest rate. Once again, we're multiplying times 1 to get the principal plus the additional interest rate that you get as a return. So $100 times 1.1, it gives you 110 in year number 1. Future value in year number 2 is the present value times 1 plus the interest rate square. Why is that? Because you take the future value from year number 1, the $110, and then you multiply it again times 1.1 to see how much you get in year number 2. So future value in year number 1 times 1.1 is in fact present value of $100 times 1.1 square. In this case, future value in year number 2 is $121. It's easy to see that present value in year number 3 will give you the present value times 1 plus the interest rate to the power of 3, which gives you $133.10 or 10 cents. Very easy, you can observe that after n years, n can represent any number of years that you want. Future value in year number n is the present value times 1 plus the interest rate to the power of n. Now, in order to solve more complex problems, we're going to use a financial calculator. There are many different financial calculators in the market. I can only recommend you to use the Texas Instruments financial calculator simply because for those of you who will pursue the CFA program later on in your life, it's kind of mandatory to use the Texas Instrument, but it doesn't have to be this. There are HP calculators, there are calculators by Casio and so on, but just for the example, I'm going to demonstrate here how to use a financial calculator. A financial calculator, Texas Instruments BA2 Plus, for example, this is something that is very popular these days. So first of all, there is the on and off button here. Now, on the financial calculator, you can see different keys. So for example, you will see N represents the number of periods or the number of years. I/Y here represents the interest rate or the yield that later on we will see when we will discuss bonds. PV stands for present value, PMT stands for payments, FV here stands for future value. So as you can see, a financial calculator has all the different keys and others that you will see later on in this course. Okay, later on we'll also discuss NPV, net present value of a project, IRR, internal rate of return, different cash flows, and so on. So here's how to solve a simple example in a financial calculator. Let's say that you want to find out what is the future value of $100 invested today in 3 years with an interest rate of 10%. In a financial calculator, you need to understand that you insert the numbers exactly as you will write them on a timeline. In other words, first you need to invest $100, so that's a negative cash flow, and then you will receive a future value. So if you insert a negative cash flow, later on you will receive a positive cash flow. However, if you receive a positive cash flow today, later on you will have to return this amount back to the bank, to the lender, as a negative cash flow. In other words, money will have to leave your pockets. So here is what we do. First, we insert the numbers. You put $100 with a minus, you change it to a negative number, so that's an investment, and then you click on present value. After that, you insert the number of years. So 3 will be N, the number of years. 0 payment, 0 PMT, because there are no additional cash flows on the way. Now we need to insert the interest rate. 10% will be I or I/Y, the interest rate. And then we ask the calculator, compute the future value. So you click on CPT, compute future value, and the answer is $133.10. Please notice that this is a positive cash flow after we invest $100. So first you invest and then you receive. Let's clear this and let's do the opposite. Let's imagine that first we receive $100. This will be our present value. 3 will be the number of years, N. 10 is the interest rate, I/Y. 0 are the payments because there are no additional values and additional cash flows, and then we ask compute the future value. Pay attention that when we receive first the present value of positive cash flow $100, then we need to pay back minus $133.10.